Before we start this video, a large thank you to B3, Laurent Demeter, Adam Coppens, Seth Herfgott, and John Rubisov. Again guys, apologies if I pronounced any of your names wrong. Your support is greatly appreciated and I hope you guys enjoy the video. Hello guys, and today we're going to start our AI system. So let's knock down this wall real quick. And the concept of today's video will be AI detection. So we're going to make it so this gentleman over here will be able to detect when he sees us, but only when we're within eyesight of him. So let's open up our enemy manager, which right now is completely blank. Now let's get started. I'm just going to throw down an awake method here, like so, and throw down an update method because we're going to be utilizing both of these. So, next I'm going to say private void handle current action. Now I'm going to do some things in this video that might not make sense at first, but I assure you they will. So just follow along and don't worry if you're slightly confused. But honestly, most of you, if not all of you, will get this. It will be relatively straightforward. So we're going to say bull is performing action. That will be for the next video. Just going to put that there now just because that will tell us when our enemy is actually doing something aside from looking for us, like moving or attacking or, doing some sort of action. Next, we're going to go and add a component to our enemy. We're going to call this enemy locomotion manager. Now, you'll notice we have a locomotion manager on our player as well. We're going to make our enemy very similar to the way we make our player, so that way we can do multiple types of AI. You know how in Dark Souls some of the enemies actually behave like a PvP player. They do the lock on, the multiple, the rolling, the two-handing, etc. So we're going to set up our AI system much like we set up our player's system. So we're going to put a namespace here as is per tradition. Mine is going to be SG for Sebastian Graves. Yours could be whatever you would like. Okay, and we're going to backspace there. And first, we're going to need a couple things here. We're going to actually make a public void called handle detection, which is the function of this video and the purpose of this video. This will serve to actually detect when our enemy sees a player. So we're going to say, we're going to make an array here for colliders, and we're going to say equals physics dot overlap sphere. And we're going to say transform.position. That will be the starting position as this enemy. And the radius will be our enemy manager dot detection radius, which we have not made yet. So I'm just going to put in enemy manager dot detection radius, and we're going to go ahead and make that variable shortly. And we're also going to only cast this on the layer called detection layer, which we haven't made yet. So that way it's only sorting through the layer which we have tagged. We're going to tag it some like characters. That way it's not searching every object it collides with or every collider. Hope that makes sense. Okay, so next we're going to make an enemy manager variable. Obviously, put that on the awake. We're going to say enemy manager equals get component enemy manager. And then we're going to head over to the enemy manager and actually make the variables for detection radius. So before we do that though, we'll make a detection layer here. So we're just going to say layer mask detection layer. If you want to, you can make that public instead of actually assigning the number in starter awake, which I will probably do. So let's go to enemy manager and we're going to say, let's go down here and say public float detection radius. So this will be the radius of the circle that encompasses our enemy that he's able to detect us in when we walk into it. So the bigger the radius, obviously, the further away this guy is able to see you. We're also going to make it so he can only see you if he's looking at you, as I said before, but we'll get to that shortly. Okay, moving swiftly along here. Let's go down here and say for, and then we're going to say colliders dot length. So for every collider that this enemy is detecting, that is in the detection layer, which will probably be a layer we call character or player. Character most likely, because you can have enemies fighting other enemies too. So see how we have player stats here and enemy stats, and notice how they're very similar. I'm going to do something really cool here now. So they're a mono behavior right now, but we're actually going to go and make another script. So, no, that's the wrong folder, script folder. Let's actually organize this a little bit first. I'm going to do most of this off video, but I'm just going to make a couple folders here. We're going to call the first one managers. We're going to make another folder. We're going to call this one UI, so everything to do with UI. And then let's quickly look for all the UI stuff. If I don't get everything right now, that's okay. I'll do the rest off video because this isn't too important to the process. Okay, yeah, let's drag that in there, free up some space, and minimize that again. Let's make another folder in here, and we're going to call it player. And yep, there we go. Okay, that looks good. The animation handler, yes, the camera handler, character manager, actually that's not player, that'll be manager, input handler, player attacker, inventory locomotion, manager stats. And yeah, it's good for now. We'll get the rest of these off video because you guys don't need to see me do this. Anyway, back to what I was saying. So we're actually going to create a new script now. Let's do that. Make a folder first, sorry, for AI before I forget, and quickly drag these in here. Okay, cool. So let's go to the managers folder and create a new script. We're going to call this character stats. And we're going to open this up in our visual scripting here. We're going to say namespace SG, Visual Studio, sorry. And then we're going to go back to our player stats and enemy stats. And we're going to do something pretty cool. We're going to make it derive from this class. And you're thinking, well, Sebastian, what's the point of that? You're going to see. So let's say character stats. This is why I said this might not make sense to you right away. Let's save that and let's go to the player stats and also make it derive from a character stats. Okay. Excellent. That's on error there, but I don't think that's an error. So you'll notice that the enemy stats and the player stats actually share these things for health and such. So let's just, what we're going to do is we're going to copy the health and stamina settings because we're going to give our enemy stamina later as well. And we're going to erase them from both classes after we copy them and throw them onto the character stats. You're going to see a bunch of errors and you're going to see them all disappear. This is because these are what we call shared variables, and both classes can take them. Now, the real main reason I'm doing this, actually, not just for simplicity in code, but if we go in here now, oh, this is just an internet error. Just clear that. That's nothing. If we go into our enemy manager or locomotion manager, now where handle detection happens, we can actually create a variable and call it of type character stats, and basically we'll detect anything that's on the detection layer that has a script type of character stats, but our player stats and enemy stats actually derive from character stats, so they count. And the reason why I'm doing this is now we don't have to make a method to detect both types, because you will have AI that will be able to fight other AI. And instead of saying, oh, if you have player stats or if you have enemy stats, you can just say, oh, well, if you have character stats. So we're going to say character stats equals colliders i.transform.get component character stats. And then we're going to say if character stats does not equal null. So if you're detecting something on the detection layer that has a character stat script or player stats or enemy stats, then we're going to do some actions. First, we're going to create a little dash line in the code here and say check for team ID. And that means we want to check and see if this enemy is friendly or not, because you can have AI that are on the same team or a different team. You know, like there's red phantoms or white phantoms, and then there's like AI that will attack each other or won't attack each other. Like the dark wraiths will attack the Gru and such. So anyway, I'm getting ahead of myself. We're going to say vector3 target direction equals character stats.transform.position minus transform.position. And then we're going to say float viewable angle equals vector3 angle target direction transform.forward. And we're going to say if the viewable angle is greater than enemy manager.minimum detection angle, we haven't made that variable yet, don't worry. And if it's less than enemy manager dot maximum detection angle. So basically, if you find something on the detection layer that is a character stat script and it is within our field of view, meaning if it can see us, then we're going to say current target equals stat or character stats. We haven't made current target yet either. So in short, what this function is going to do is it's going to look for something on a certain layer, and if it finds something and that has a character stat script, and then it's within the field of view of the enemy that's searching, it will then add it to its target list. So we're going to say character stats current target up here. That'll be our variable. And then we're going to make these variables for minimum detection angle and maximum detection angle. And don't worry, I will make all this make sense. I'll clarify it again in just a few moments. I'll expand upon it further. So over here in our enemy manager script, we're going to say public float maximum detection angle, and we're going to initialize that at 50. I found 50 to work perfectly. You can do it at whatever you'd like. And then we're going to say public float minimum detection angle, and we're going to initialize that at minus 50. Again, I found minus 50 to be absolutely perfect. You can change that if you so desire. And now to add a comment to this, basically what this is doing is the higher the maximum detection angle is, the greater, and the higher the maximum detection angle is and the lower the minimum detection angle is, so if you put it to minus 75 and plus 75, you're going to expand your enemy's field of view. So think of it in terms of like eyesight, okay? So if you crank that maximum number up higher and you put that minimum number down lower, you're going to just put your hands on the sides of your eyes and eliminate your peripheral vision, and then slowly open them up. And that's what you're doing. You're giving this enemy more peripheral vision to a point where you could actually make it so they can see in a 360. But we're going to do it so it can only see dead ahead and just slightly off to the side. And that's what 50 and minus 50 will do. So now, again, going through this one more time, it's going to look for colliders. If the colliders are on the detection layer, which we will call like characters, it will go through and look for a character stats script. If it finds one of that and it's also within the field of view, it will then add it as a target. So let's add a layer, and then we're going to call this layer, I'm going to use layer 9. I'm just going to call it character because anything in the game that's a character will use this layer. And then on our player, I will assign that, and I will say no, just the object up here we're going to change. So our main object will be a character, will be on the character layer. And then on our enemy, what we want to do is, I think we forgot to assign the detection radius. Yes, it's actually at 0. We forgot to initialize that. So let's also put the detection layer on character, and let's crank up the detection radius to 20. I'm actually just going to make this public so we can see when we have a target. And I'm going to go to the enemy manager, and I'm going to do a couple of things here now so we actually use their functionality. We're going to say if enemy locomotion manager. We haven't actually called the variable yet. So let's just put that there for now like that. Let's copy that. Let's make a variable for enemy locomotion manager. AI is so fun. Okay. Enemy locomotion manager. And on awake here, we're going to say enemy locomotion manager equals get component enemy locomotion manager. Now down here, we're going to say if enemy locomotion manager dot current target equals null. Then we want to handle our detection and find a potential target. So we're going to say enemy locomotion manager dot handle detection. And then we're going to call handle current action on update. You can see how this is going to work now. Excellent. Okay, so we would have to initialize our detection radius at 20. Since we didn't and already saved it, I'm pretty sure it will just be at 0 when we go in the game. So let's also change that in the inspector. And yeah, that is. So let's say 20. Okay, cool. Let's see. We have 0 targets now. If you look down there, let's start the game. And boom, yeah, we have a target. Our enemy locomotion manager is actually detecting our player as our target. You see down there in the inspector. So let's try something. Let's actually turn him around now so he's back onto us. And we want to make sure he doesn't detect us when he's back onto us because we're not in his field of view. So let's turn him this way. Am I recording? Oh, yeah, I am. Okay. Let's turn him this way and hit play. And now if you pay attention to the inspector, yes, he has no target. So it's his current target, none. Let's tiptoe up to him now. We can actually make it later so he can detect us with sound too, but we're getting ahead of ourselves. So, see, look, he cannot see us. No current target. If I go in front of him, boom, we are his target. Excellent. And that is the foundation of our detection system. And we're going to expand on that in further videos. In the next video, we're going to make the AI walk at us if he has us as a target, or run to us depending on the distance he is away. So if he's farther away, he'll sprint. If he's closer, he'll walk at us. Very exciting. AI is very awesome. I hope you guys enjoyed the video. Please do not forget to drop a like. It genuinely helps my series out so much. If you're feeling even more kind than that, leave a comment. If you're feeling like a complete champion, check out my Patreon below, guys. Much love, and I will see you in the next one. Peace.